Working on lesson 12, we're working on the student outcomes of knowing that when you have a set of parallel lines, your corresponding angles, your alternate exterior angles, your alternate interior angles all have same degrees of measure, okay, with parallel lines. So we start out by looking at two lines that are not parallel. Line number 1 you found to be a degree measure of, wait, before I do that, I want to show you, those of you who are a little unsure of using a protractor, remember the key to a protractor, where you are measuring, the angle you're measuring has the center of the protractor. You then line 0 up with the line. Okay, there are, on straight lines, a measurement of, there is a measurement of what? How many degrees is a straight line? It's not 0. It's 180. All straight lines measure to be 180 degrees. So now, when you found the measure of this one, angle 1, you found it to be approximately what?
115.
I got
Really?
I got 117 on my protractor.
No.
I would accept any answer within 2 degrees.
Oh, I just.
Okay? I would accept any answer within 2 degrees. So when we think about what we know about angles, right now we know that a straight angle has a degree measure of
180.
180. We measured angle 1 and found it had a degree measure of 117 degrees. Do I have to measure angle number 2?
No.
Why not?
You could just. Oh, I'll read.
I can do the math, which is
180 minus 117.
180 minus 117 degrees. Is there any way that that measurement of angle 2 can be anything different?
No.
No. So this is 63 degrees. Now, without doing any more math, what other angles do I know?
You know number 3
is
and 4.
117, and you know number 4 is 63 degrees.
Okay, I know that angle number 3 has to be 117, and I know it for 2 different reasons. Give me one. Sutter.
Because it's like the same.
Why? Because of what relationship?
There's a word.
Yeah. They're directly across from one another, and that vocabulary word is
Hang on.
vertical angles. Very good. Okay. 2 lines that intersect create opposite angles of vertical angles, and they have to be the same degree of measure. What is the second relationship that tells me this has to be 117 degrees? Yes.
Because there's a line going that way and that's 63.
Very good, because right here, angle 2 to angle 3 makes a 180 degree angle. That relationship is called 2 angles whose sum is 180 degrees are, yes?
Supplementary.
Supplementary angles, very good. Okay, because these 2 have to be 180 degrees. This one is 63, this one has to be 117. And therefore I also know
That is 63.
angle 4 also has to be 63 degrees because of the vertical angle relationship and the supplementary angle relationship. Are there any questions on knowing those angle degree measures? Did you find that these angles down here had the same degree of measure? No. So when you do not have parallel lines, the angles created with the transversal creates different degrees of measures. Angle 5 was
105 degrees.
105 degrees. I think I got 104, again within 2 degrees will be correct. Then 6 has to be
75.
75 degrees. 7 has to be
105.
because
It is supplementary.
it's supplementary to 6 and vertical to 5, and 8 has to be
75.
75 degrees. Are there any questions about the rules of supplementary and vertical angles? Everyone understands that if you do not have parallel lines, you do not get matching angle measures between the two lines cut by the transversal.
Yeah.
Main idea. Press stop.